Guys, welcome back here at the EC Engineering tutorial. So this time, let's continue our discussion on the design of drainage channel. Okay, so let's continue in canal cross-section. So the recommended shapes for canals are trapezoidal or rectangular, for line channel or rock formation due to their stability and higher resistance to scouring. So, yung derivation ng weighted perimeter natin is ito yun. So, like, diretso na ako dito, no? So, bali yung perimeter natin is just P plus 2C or B plus 2 multiplied by the depth, square root nung side slope squared plus 1. And for the weighted area, is ito yun, B plus the side slope depth multiplied by the depth. So, very important formulas. Anyway, meron tayong summary ng mga formulas na ginagamit natin for our canal, no? So, for rectangular channel, we have this area, ito yun, weighted perimeter, hydraulic radius, top width, and hydraulic depth. So, meron tayong ganito mga formulas. Okay? And we have also trapezoidal, no? So, we have area, weighted perimeter, hydraulic radius, top width, and hydraulic depth. Take note, yung formula niya is naka in terms of side slope, no? Kasi one parameter in the design of canal is yung side slope, no? Kasi meron tayong mga criteria for side slope, no? That we take account in the design, no? Kaya yung formula nito is very useful kasi naka-side slope na siya. Okay, so for triangular na channel section, again, we have this area, weighted perimeter, hydraulic radius, hydraulic depth, and top width. And again, in terms of side slope, we have this side slope Z. And for circular, we have this different formula in terms of theta. And for parabola, so we have this area, perimeter, hydraulic radius, and depth, and the top width, no? So meron tayong ganitong formula in terms of the top width T and Y. Okay, so ngayon, punta tayo dito sa most efficient section or best hydraulic cross section. So marami tong pangalan, no? So it could be cross section of greatest efficiency or best hydraulic section, minimum weighted perimeter, most economical section, most advantageous section, optimum section, maximum discharge. So munang gingon nga sa na all, no? So nasa iya tanan. Okay, so mo po na itong ginagamit sa design kaya mas ito din yung ginagamit natin sa design kasi mas nakakatipid tayo, no? Mas economical eh. So first is the rectangular. So for rectangular section, for most economical section, yung B is just twice nung depth and yung hydraulic radius is just the depth divided by 2. And for trapezoidal, so half lang ng hexagon. So bali yung theta dyan is 30 degrees. So kung dito ka mag-start, bali with reference to vertical axis, 30 degrees yung theta. With respect to horizontal axis or x-axis, 60 degrees or half ng hexagon. Again, yung hydraulic radius is depth divided by 2. So for triangular section, so yung theta must be 90 degrees. No? So bali right angle to. No? Right angle. Again, B is twice nung depth. Area is D squared. And for semicircular, and we have 2R and depth. So, yung hydraulic radius is just R divided by 2. Ngayon, kung nangyayari na common yung area nila, so for different cross-section having the same area, or common yung cross-sectional area nila, ngayon mamimili ka, no? For instance, common yung mga area nila, mamimili ka kung sino dito ang mas mura, di ba? Or most economical. E di, yung yung may maliit na perimeter, no? Okay? Or you can also use this formula, no? So you have this cross section and you have this weighted perimeter. Dapat perimeter to hindi area. Okay? So for common area, pipili tayo ng pinakamaliit na perimeter. Anyway, meron tayong mga formulas for different cross section. Ayan. So sino yung maliit? Siya yung mag-govern, no? So we have also naka-table form for geometric characteristic of these hydraulic sections. So area, perimeter, and top width. Okay? Okay. So this is just the derivation for this hydraulic section for rectangular channel and also for trapezoidal channel and for triangular channel. So for circular channel, we have dalawa, no? Depende kung ano yung gusto mo makuha. So if your goal is to have a maximum flow of water in a circular channel, dapat yung depth ng water mo is equal sa 0.938 nung inner depth ng channel mo. And kung gusto mo nang makuha is yung maximum velocity ng water in a circular channel, so it must be 0.81 nung inner depth. Okay? Inside depth, inner depth. So the choice of best hydraulic section also possesses other advantages than hydraulic performance. For instance, given discharge rate, the use of best hydraulic section could guarantee the less cross-sectional area of the channel. So substantial savings could be made from the reduction in the amount of excavation and from the use of less channel lining. It is characterized by provision of maximum discharge with a given cross-sectional area. So maximize the flow for a given cross-sectional shape and area. So let's have an example for most efficient sections. So a rectangular channel which is 5.4 meter width by 1.2 meter depth is lined with a smooth stone well laid and has hydraulic slope of 0.001. So use yung roughness coefficient natin na 0.13. So ano daw yung capacity ng channel in cubic meter per second? Tsaka ano yung savings in earth excavation could have been offered by using more favorable proportions but adhering to the same delivery and slope. And ano yung savings natin in lining per meter length by the use of favorable proportions but adhering to the same delivery and slope. Okay, so let's solve this one. So we have a rectangular section. We have B over D. B and D. So yung B is 5.4 meter. Tsaka yung depth ng water is 1.2 meter. Okay, so yung area bali is 5.4 times 1.2. We have 6.48 square meter. And then yung weighted perimeter is we have twice nung 1.2 kasi meron kang 1.2 sa gilid nila, itong side. Tsaka dito sa bottom, you have 5.4. So a total of 7.8 meter. So ma-solve mo yung hydraulic radius which is just the difference, the ratio of weighted area over the weighted perimeter. So you have 0.831. Ngayon, kung meron ka ng ganito, area, perimeter, and hydraulic radius, we can now solve for the capacity of the channel. No? So using the formula of continuity equation, area times velocity, where velocity using Manning's formula is 1 over nr, 2/3 s, 1/2. So we just need to put all the values in the formulas and we get the flow rate of 13.93 cubic meter per second or cumics. Okay, cumics. So yan na yung sagot. So for problem 2, ano daw yung savings na makukuha natin sa excavation? So kung gagamit tayo ng most economical section or most efficient section. So bali yung B natin is equal nung twice ng depth, di ba? So bali yung area natin is 2D squared, yung weighted perimeter natin is 4 times the depth. So bali yung hydraulic radius is D divided by 2, no? So using the continuity equation, we have Q is equal to area times velocity, where velocity is 1 over n, r 2/3 s, 1/2. And yung flow rate nga nakuha natin sa part 1 is 13.93, no? Kasi yung goal natin is adhering the same delivery and slope kasi, no? Like, pareho daw yung Q, no? So, you have this Q na 13.93, bali yung goal natin is ma-solve natin kung ano yung depth ng water. So, you have 1.764. So, bali yung B mo is 3.528. So, ngayon, yung savings nung excavation mo is you have 5.4 multiplied by 1.2. Ito yung sa original, no? 'Di ba? Meron kang 5.4 and 1.2. Ngayon, i-deduct natin yung sa most economical section which is 3.529 and 1.764. So, meron kang 0.2554 square meter na savings sa excavation per 1 meter length, no? Per 1 meter length, 'di ba? So, imagine if you multiply it by 10 kilometers. Dako jug savings, no? Imagine a kilometer. Okay, so in terms of savings sa lining, again, nakuha na natin yung D tsaka B natin. So like, ito yung sa original. So, take 1 meter strip pa rin. So, yung perimeter natin sa original is 7.8. Then, times 1 meter strip, you have 7.8 square meter na. And, ngayon sa bago itong most efficient section, bali gagamitin natin yung na-compute natin na 1.764 tsaka 3.529. Ito yung makukuha natin na value per 1 meter strip, di ba? So, bali yung savings mo in lining is 0.743 square meter per meter length. So, imagine that one. Imagine a 10 kilometer length ng channel mo, no? That's a lot of savings na imong makuha. So, muna ang importansya sa most efficient sections. Okay, so another example is dito sa bend and canal. So, meron tayong rectangular channel of width 2 meter and has a slope of 0.002. Meron tayong roughness coefficient of 0.012, carries a discharge of 8 cubic meter per second. So, ano daw yung normal depth ng flow, ano daw yung velocity ng flow, at saka ano daw yung radius of curvature required for a bend in this channel if the flow is at normal depth entering the bend and the water surface at the outside wall of the bend must not be more than 0.15 meter above the depth entering the bend. So, to solve this one, first, we compute for the normal depth. So, bali yung given, B is 2 meter. Wala tayong depth, no? Pero meron tayong discharge na 8 cubic meter per second. So, bali yung area natin is 2 depth. Perimeter natin is 2D plus 2. And then, we have this hydraulic radius, which is area over perimeter. So, we have D over D plus 1. So, ngayon, meron tayong continuity equation, Q equals area times velocity, where velocity is just 1 over N, R2 third, S 1 half, pramaning. So, meron tayong Q na given 8 cubic meter per second. We just substitute that one and we compute for the depth ng water natin. So, we have 1.51 meters. So, yan na yung normal depth. So, next problem is, ano daw yung velocity ng flow? So, okay, meron ka ng B na 2 meter, meron ka ng depth na 1.51. So, meron ka ng area na, which is 3.02 square meter. Meron ka na ding velocity ngayon, no? You have flow rate na 8 meter, and then you have area na 3.02. Continuity equation is area times velocity. Makakompute mo yung velocity, which is 2.65 meter per second. Okay, so next problem is ano daw yung radius ng curvature, no? So like you have this bend, and so using this formula, like we just need to substitute all the values. This is given. So like masosolve natin yung radius ng curvature, and that is 9.54 meters. Okay, so that's it, no? So irregular channel, RVF and GVF would be done as a next video. Just keep on watching and keep on learning. See you in the next video. Thank you.